Okay, we're going to skip the warm-up just because, but I do want to show you your affirmation for Unit 8. Growth is never mere chance. It's the result of forces working together. But y'all grown a lot this year. It's been fun to watch. Okay, so Unit 8 was all about applications of integration. Once we got to the end, we kind of started limping all of those together and doing 2 things a day just to kind of get through those last few methods. But it was average value, how we connect position, velocity, acceleration, and then accumulation in general, area between 2 curves, regardless of how it was ordered, okay? Then we did volume with cross sections, volume with discs, volume with washers, all right? So those are the things we did in that. So let's just go through and just real quick, average value of function. Do you remember how we do that? Nope. Yep. Length of the interval, integral from a to b of f of x dx. Okay, so anytime you're asked to find average value, of course you can't see that because I wrote it too high. Okay, so 1 over the length of the interval times the integral from a to b f of x dx. Right. Now, remember that our accumulation model, okay, let's do accumulation first because I think it applies to everything else and it makes it a little bit easier to see. All right. We do f at a plus the integral from a to whatever we're looking for of f of x dx. That's our accumulation model. We put in what we know. We go from the x value for what we know to what we're looking for, and we evaluate the integral. Okay, so that's our accumulation. All right. Our displacement or our net change, if we're talking about motion, is the integral from a to b of f of x dx. Okay, it's f prime. We'll put f prime right there. Okay. And then for our total distance, we put absolute value around that. So our total accumulation changed. Put it in the right terms. And then if we're looking for new position, if we're doing motion, we take our starting position plus the integral from a to b of our velocity, which is the derivative of position. Okay, so all of that plays into that accumulation model that we've used before. Okay. Okay. So then we got to area between two curves, right? And basically, remember when we do that, there's a couple of things that we look for, right, where they intersect. Okay. So if I would have a vertical height then it's top function minus bottom. Right, so my area would equal the integral from a to b of f of x minus g of x dx. So we just subtract top minus bottom. And if I would have a horizontal height, we would do right minus left. So if we intersect C to D, I would get the integral from C to D, f of y minus g at y dy. So everything comes from the y-axis if it's horizontal. My nephew had a volunteer at the hospital who came by yesterday. He was a younger person who came by just to play Fortnite with him for a while, which was cute. Their volunteers are pretty special down there. I would not play Fortnite, but I would go and I'd color, and I could play Play-Doh and dolls. I'd be really good at that. That might be what I do in my retirement. That would be fun. I wonder if they ever need tutors. If they're going to be there for a long time, if they're doing schoolwork and stuff. Just weird.
That'll be good.
Himmel will be playing Call of Duty. They'd be blowing people up. Bless. I mean, but they have their Xboxes, Switches, all that's just standard in the room. So all the video game stuff. And they sent him, because during his infusion, he can't move. He has to be still for like an hour and a half. And yesterday it was 3 hours and they didn't get done. But they sent him a basket of quiet things to do. So there were Legos, coloring. There was a cornhole that you set up on the table that you could toss. I mean, there were some really neat things. I'm like, this is pretty creative. And he gets to take it all home, which is kind of cool. But anyway, that was neat. They just think of everything. Special people. Okay. So let's do a little something. This is an actual release free response from a practice exam from 2016. It's the B problem. Okay, during free response blitz, we're going to do all the problems that have names. Okay, we're going to do the Speedo problem. We're going to do the, we've already done part of the Speedo problem. We're going to do the potato problem. We're going to do the spinning top problem. That one put my kids under in 21, by the way. That was the one they were like, Miss Moore, it was complete trash. They must not have done too bad because they did great on the test, so you get one. All right, so let's take a look. So we've got a five. We are getting a 5. We've got a hive that contains 3,500 bees at time t equals 0. During the time interval from 0 to 4 hours, bees enter the hive at a rate modeled by E of t, where E is measured in hundreds of bees per hour. During the same time interval, they leave the hive at a rate modeled by L of t, where L of t is measured in hundreds of bees per hour. Now notice this is number 6, which means it's non-calculator. Okay, so that's the first thing you need to notice. It's non-calculator. So it wants to know how many bees leave the hive during the time interval from 0 to 2. How would we figure that out? We do an integral. We just want to know how many leave from 0 to 2. Okay, L of t, which would be negative 2t plus 15 dt. That's all it wants me to do. okay? So if we integrate, negative 2t would give me negative t squared plus 15t. We're going to evaluate from 0 to 2 and plug in our stuff. So I'd get negative 4 plus 30 minus 0. Or, now this is where it's going to be important, all right? It's 26, all right? If you leave it like that, you said there were 26 b's that left. How many b's actually left? 2,600, okay? So you got to pay attention to the units, okay? That problem in and of itself, not difficult. It was worth 1 point, okay? All right, good. Okay, part B. Write an expression involving one or more integrals for the total number of bees in hundreds in the hive at time t equals 4. Find the total number of bees in the hive at t equals 4. Okay, so we can kind of do this in 2 steps, or we can do it in 1. All right, how many bees are in the hive when we start? 3,500. So I'm going to keep those. All right, I don't lose any bees. And we want to go from 0 to 4. So let's talk about what happens. After that initial time, we get bees coming in and bees going out. Okay, so I'm going to do the integral from 0 to 2 of those coming in, which was 16t minus 3t squared dt. Is it 2 or 4? It's 4. Let me change that. 0 to 4. Okay, minus, I'm going to take those that are going out, 0 to 4, negative 2t plus 15 dt. Okay. And then we're going to do our integration. And it's not terrible. Right? It's going to give me 8t squared minus t cubed. That one's going to go from 0 to 4. Minus, we've already done the other one, negative t squared plus 15t from 0 to 4. Okay. The only thing I would say is just be careful about your substitution right here. Okay, because it can get you if you're not careful. Did I do that right? 16 times 8. Okay. Negative 16. 60. 44. Yeah. Okay. That's 797. Oh, minus 44. It helps if I can read my own writing. Did I do that math right? It's questionable.
Wouldn't that be 64 minus 44?
Yep. Thank you. Yes, that would make it 55. Because that's 20. Yep. 55. okay? You actually got 2 points for this one, okay? You got 1 point for using the initial condition of that 35, okay? And then if you didn't do the integrals correctly, because it said to write the expression, maybe you got 3. Maybe you got 3 points for this part. I can't remember. They didn't send me a scoring guide. Or no, I think it's still 2. You got, no, it had to be 3, because the answer would be important too. Okay, anyway, so I think you got 3 points. You got 1 for the 35, 1 for the both of the integrals, and then the answer. Okay. All right, so then we get to part C, and part C is where it gets a little bit tougher, okay? Because this is talking about finding the minimum number of bees in the hive, okay, between 0 and 4. Anytime they want me to find a minimum, we got to think about that candidate's test, especially when it's a closed domain, okay? And that closed domain is from 0 to 4, okay? So let's think about the total number of bees. How did we define it up here? Okay, my total bees would equal 35 plus the integral from 0 to whatever we're doing, all right, of E of t minus L of t dt. Does everybody agree that that's what we did? Okay. Now, we use 2 integrals, but you can put it as 1. Okay. That's what we did. So this would represent total bees. Right? In order to find a maximum or a minimum, we have to find a derivative. Okay. We have to find a derivative. So t prime would equal, derivative of 35 would be what? 0. Derivative of this integral would just be e to the x, e of x minus L of x. Okay? Now, the good news for me is that they defined e of x and L of x. So here's what we're going to do. T prime is going to equal, e at x is 16t minus 3t squared, minus L of x is negative 2t plus 15. So I'm going to actually be able to get an expression here. All right? Why is getting an expression going to be important? To find the critical points. Okay? Because in order to find our maxes or mins, we have to find the endpoints and the critical points. Right? So t prime at x is going to equal negative 3t squared plus 18t minus 15. And then we're going to set it equal to 0. Right? Now, lucky for me, guess what I can factor out? A 3. In fact, I'm going to factor out a negative 3. Okay? So that's going to give me a negative 3t squared minus 6t plus 5 is equal to 0, which factors into t minus 5, t minus 1, okay, or t equals 1 and 5. Okay. Now, when we go to our candidates test, right, so we have x and we have t of x. So this is an involved problem. In fact, it's worth 5 points for a reason. Okay, every question's worth 9, and we've had, what, 3 points so far? All right, so, or maybe, no, we've had 4, so this is the 5 points, all right? You're getting points for all of this work, okay? We know the 2 endpoints were 0 and 4, okay? We knew that, all right? We knew it was 0 and 4. Which of these critical points do I have to test? Just 1. 5 is outside the interval we're talking about. Swing. All right. So that's going to save me some time. Okay, that's going to save me some time. Now, the good news is if I think about my total number of bees, if I plug 0 in, what do I get? 0 for the integral, which is 35, which they told me. Okay. And then lo and behold, in part B, we already did 4. Okay. And what was the number for that? 55. Okay. So the only thing I really have to evaluate in this problem is the 1. Okay. In that integral. Again, good news. We've already done the integral up here. We just have to plug in the 1. All right. We did it right here. Okay, so I can evaluate 35 plus, right? If I plug a 1 in, 8 times 1 squared is 8, minus 1 cubed is 1, 0 is nothing, minus, on the other one, negative 1 plus 15. Okay, so I've already done the work to be able to evaluate. I'm not doing the work twice, right? So we get 35 plus 7 minus 14. Okay, so it's going to give me a negative 7. Do I get 28? Okay. Whew. We've done a lot of work. Let's answer the question. Yes. Yes?
Could we say, since there's only one turning point on this interval, and just plug in arbitrarily 0.5 and 2, we can see that that's a minimum, and then just say, since there's only one minimum, therefore that has to be the absolute minimum on the
If you wanted to test it like in a sign chart,
Yeah.
yes, you could do a sign chart. But you would have to show the sign chart, and then you'd have to say a lot of words to go with it. Yeah. This is their go-to in terms of grading, but that would work as well. You could also do a second derivative, do the second derivative test and talk about concavity. We could do that. Yeah, so there's a couple of options to get here. Most people go straight to the candidates test. Okay? All right, so we get 28. So now let's answer the question, which was, at this point I've forgotten, the minimum. Okay, so what's the minimum number of bees in the hive? 2,800. Okay, so we say the minimum number of bees is 2,800 at t equals 1 because t prime at 1 is equal to 0. That's it. Right? That's a really, really, really good free response question. Okay? Anytime that it's something about proving a minimum or a maximum and it's application based like that and you have to get into a candidate's test, it's worth more points than other parts. Okay? That could have been the first question, but notice they led you to it. Okay? I don't want to trick you into thinking that the parts get progressively harder. Sometimes they don't. Sometimes the first part's the hardest and the bottom part's the easiest. But when it's doing candidates test, usually it's going to lead you through some of the stuff you need before you get there. So that's why they do it that way. Okay? Yes, sir. Yes, you may. Okay? All right, so let's just look at a few more free response questions, okay? That's what I've got on all the other pages, so I know it looks long, but I've just put free response questions everywhere. All right? So you start to get a feel for most of Unit 8 will show up in free response. Okay? It's just where they choose to put it. So let's take a look at this next one. And we'll just go through what we can get through, and then we'll leave it at that. Okay. This one is very similar, okay, but it uses a graph. Okay, it uses a graph. Okay. How are we going to evaluate integrals if I have a graph? Area. Okay, so that's why they like this one. This is number 3. It too would be non-calculator. Okay, this is from the 2010 test. Okay, so it would also be non-calculator. Right. It says there are 700 people in line for an amusement park ride when the ride begins operation in the morning. Once it begins, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph shows the rate at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. Okay, so how many people arrive at the ride between t equals 0 and t equals 3? What are we looking to do in this part? Yeah, we're going to find the area. We need the integral from 0 to 3 of just how many people arrive at the ride between 0 and 3. And did they call it R of t? Yeah. dt. Okay. So we're going to do area from 0 to 3. All right? Lots of ways you can compute that area. I'll let you think about it. Okay, I did 4 shapes. You can do as many or as little shapes as you want, but those were the 4 I saw. All right, 2 triangles and 2 rectangles. And then I didn't do all that calculation, but I got 2,400 plus 400 plus 200 plus 100. So 3,700. Did I miss one? $202, 3 and 800, 1/2, 1 and 400, 1/2, 2 and 200. Okay, I did that right. Oh, it's 200 right here. All right, so that gives me 3,200 people. All right, it's worth 2 points. Okay, you got 1 for stating this integral right here, that's what you were doing. And then you got 1 point for the answer with units. Okay, so that was part A. Okay, part B. Is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Justify your answer. All right. This one actually comes from the stem itself. Okay. It says, while there's a line, people move onto the ride at a rate of 800 people per hour. Are we going to have a line from time between 2 and 3 hours? The answer is yes. Okay, we are. Okay, we've got a line. So between 2 and 3, because it says once we start a line, which happens as soon as it opens, okay, then, and it keeps a line the whole time, right? So that happening, what is true about that rate between 2 and 3? Because it's constant, what is it? What's my rate? It's 800. And if my rate is positive, what does that mean is happening to the number of people? My derivative is positive. It's increasing, okay? So we would say the number of people waiting in line is increasing. Right, because people move onto the ride a rate of 800 people per hour. And it's because it's positive. Yep.
The answer is right, but the justification's people move onto the ride at a rate of 800 people per hour while there is a line, but we're asking if the number of people waiting in line is increasing or decreasing. And the number of people who arrive at the ride is greater than 800 between 2 and 3, like per hour. Therefore,
This is what you want. I got the official scoring guide. I'll read it to you.
that doesn't make sense though.
It says the number of people waiting in line is increasing because people move onto the ride at a rate of 800 people per hour between t equals 2 and 3. R of t is positive. Because we're talking about the derivative has to be positive for the number of people to increase. Okay, the rate is people per hour. So for the number of people to increase, then the people per hour had to be positive. The derivative had to be positive for the function itself to be increasing.
Yeah, R of t is positive.
Yep.
And people get onto the ride at a rate of 800 per hour. R of t is the rate at which people arrive at the ride.
But we're talking about the number of people waiting in line.
Well, yeah, but that's going to be R of t minus 800. So we have how many people are able to get out of the line and onto the ride?
It doesn't tell me that, so we can't think about that part because it didn't tell me. I didn't say it's a good problem. I didn't say it's a good problem.
The answer
No,
doesn't
but
make
people
sense.
moving onto the ride is
800 is the people getting onto the ride, not the people getting into the line.
yeah, it's the people getting out of the line too.
Yes, that's
Yeah.
the people getting out of the line.
Yeah,
We're asking if the line is increasing or decreasing.
is
So
the
the rate of
justification
change of the line is going to be the rate of change of the people arriving minus the rate of
that-
change
yeah.
of people
Is that what the
leaving.
justification means though? Because the rate of people getting out of the line is the 800, and then you're saying that.
We're going to get to the total people in the line in a second. We're going to address the 800.
That's not. that's not
On,
talking about
it's in
that.
Part D. Yeah, we address it in Part D. Okay. All right, let's keep going. We'll come back and we can fight later. All right. So it says, at what time t is the line for the ride the longest, and how many people are in the line at that time? We got to justify ourselves. Okay. So we got to think about for this one. This is that maximum, minimum, all that good stuff, right? So, so the number of people. So where is this R of t, this picture, equal to 800 at what time? Oh, eraser. Because we got to know where it breaks even, right? Okay, because we know we're getting on the ride and we're getting in the line and all that stuff, right? It has to break even, all right? When that R of t, it happens when I got how many people? 800, okay? And when does this picture that they gave me equal 800 at what time? At 3, okay? So at t equals 3, so that's one of our options. The only other options, okay, would be at the beginning or at the end, right? Okay, because we got finite values there if you're thinking your candidates test, all right? So at t equals 3, right, our rate would be 800, okay? And so then we would assume it would not be longest in the beginning or at the end, but we could figure it out, right? Because how many people do we have there at t equals 0? We got our 700? Yeah, okay. And so then if we added in everything else, so we'd have 700 to start at 0. No, I can't really call it RT. I don't know what I'm going to call it. Let's call it P of T, people. I got 0, I've got 3, and then I've got 8 hours later. Okay. We know they're moving on to that ride following my function, all right, what I've got up there. And then they're coming off at that 800 for every hour, all right? So that's what Gareth was talking about a while ago. All right, so at 3, all right, we'll figure that one out in just a second. All right, but at 0, I'm just going to have the 700. All right, at t equals 3, all right, we'll have our 700 plus we've got that area from 0 to 3, which we did already, okay, of RT, all right? And then we got to subtract out that 800 that have been doing that for 3 hours, okay? And so if we do that, that would give me 1,500, all right? Because this one's 3,200, we already did it, that integral, right? So then let's evaluate it again from 0 to 8 minus 800 times 8, right? So they're coming in, based on my function, they're going out the line at 800, okay? So we basically need the area of the whole blasted thing, all right? We've already done 0 to 3. Could we figure out the rest of it? Sure, okay? But because, as Gareth said a few minutes ago, it only has one turning point, what's that one probably going to have to be? It'd have to be our maximum, all right? But we can figure it out, all right? We already know 0 to 3. We could figure out the rest. That last one's a trapezoid, all right? So if I do those parts, 1/2, 1 times 4, so 200. And then this one, 1/2, 1, 2, 3, 4, 5, plus 1, 2, 3, and my height, 400. So that's going to give me 200 plus 20 times 8, 160, which would be 360. Okay, so I'd have 700 plus 360 minus 6,400. Yeah, we get a negative. Okay. So that's definitely not going to be a maximum. Right. So we would say, at what time is the line the longest? All right, the line's longest at t equals 3 with 1,500 people in line. Okay, your candidates test is your justification, which is nice. That was worth 3 points. Okay, you got 1 for showing that it was t equals 3, so that was 1 point. You got 1 point for the number of people. And then you got 1 point for all your justification, which is all that work we did. So it was worth 3 points. And then part D is probably the easiest part of the whole problem because it just wants you to write an equation. All right, it says write but don't solve an equation involving an integral expression of R whose solution gives the earliest time t at which there will no longer be a line for the ride. Okay, so for part D, if I don't want there to be a line, how many people do I want? 0 equals 700 plus the integral from 0 to t, we'll call it r of s ds, minus 800 t. It's that calculation we've been doing. Okay. That was worth, are you ready? 3 points. You got 1 point for the 800t. You got 1 point for the integral. And you got 1 point for the whole equation itself. That felt like 3 points. All right, just writing the equation when they give you points like that. Okay, they don't always do it, but sometimes they will. Bless you, bless you. Okay, we're going to do a lot of free response so you get used to kind of the nuances of how they're asking things and what they're looking for, because sometimes the problems are crappy.
Sometimes they won't have the justification.
Okay, you are correct. All right. But you'll begin to see patterns, which is kind of cool, right? They can ask you lots of different things in lots of different ways, but you start to see some patterns the more you do. As we get closer to D-Day, all right, free response is where you need to focus your time, effort, and energy, because it will, it just will make up the difference for the mistakes we'll make in multiple choice. Okay? Oh, no. Oh, no. Oh, no. Whew. This coach just sent me 2 words. One of them's not nice. Okay. How about testing today?
You know, for the, did you ask him? I didn't ask him. Okay, so we got attendance papers for the ACT where we could miss a day and
Oh.
like it would be covered. But we asked the lady and she said she didn't know if it worked. Like she didn't know if they.
Know how it worked?
No, she didn't know if you would be able to use them since you didn't use them the first semester. But it wasn't the attendance book. It wasn't Miss Baker.
Mm-hmm.
That was was Miss Slaughter doing it? Yeah. Yeah. Miss Baker's on.
I would assume, I mean, it
have
didn't
to
say a date on it, right? Like, I would think you could use it whenever. Does it only count for one class?
One day. It's just one day.
So that would apply to the whole day. So you'd have to show it to every teacher so they know. I mean, like, we'll count you absent, but what we won't do is, let me get some clarification. I want to be sure we get that right. Because, I mean,
It said just give it to the attendance clerk office.
oh, okay. So, like, we'll mark you absent, and then you'll give it to her, and then she'll fix it. That's what will happen. I'll mark you absent, and then you'll give it to her as your excuse note, and she'll take it out. Okay, yeah, that's easy.
What if you were barely tardy for one day? It was the one day that stopped you from
You could turn it in for that, I would assume.
because my record would be perfect for this
Okay.
year at least.
I think that would be justified.
Can you use parent?
I was barely asked.
Yes. Yeah. But I think it goes in with the normal, like you get 5 total, so you can use it for a tardy or an absence or.
I do not. Don't lie. I do not.
Okay, gosh, that I was like, I don't
What's the
think
real
so.
Okay, the real number is 15. 5 of those are from doctors, and I just turned in the doctor's
Atta girl.
notes. So.
You still have 10
10.
parties?
Ten.
But I haven't used any of my parent notes.
There you go.
So I have, no, that's 10, 5 each semester.
Yeah, because prom tickets are coming up.
Yeah.
Oh, yeah.
So
They'll be
I
looking
just-
at the tardies.
I'm getting rid of all of them. And
How
I'm
many
good.
tardies is it?
No, 10.
Okay.
Excuse all of them. I used none of my parent notes.
Stop being late.
Just lock
Sometimes it's
it.
not my fault. And it's not even always late. It's usually you get taken out of class early. Yeah. Yeah. And being late.
Wait, weren't you marked
Okay.
tardy like 2 times for being like taken out by Mr.
Yeah.
Okay, let's do one. I mean, let's keep working. Okay, I'm not totally over it yet, but I'm close. Okay, here we go.
Are we gonna get to go to the co-op or something?
Listen, I don't know. I'm just telling you, she sent me 2 words. Okay, the last one is show. You can figure out what the first one is. Okay.
Talent show?
Yeah, that's exactly what it was. Oh my gosh, as I'm recording. Okay, here we go. Please don't play this for your parents. All right. All right, see if you can do part A.
You don't know.
I'll whisper it to you. Actually,
Here, look, I'm just gonna do this.
Oh wait, I know what it is.
Okay, God bless. Bless it. Jawak, we love you.
Oh god. I figured it out eventually.
Okay,
just took you forever.
Okay.
it's okay. Here we go. Rocket A has positive velocity VFT. After being launched upward from initial height of 0, time t equals 0, the velocity of rocket is recorded for selected values of t over the interval from 0 to 80, as shown in the table. Find the average acceleration of rocket A over the interval from 0 to 80. Indicate units of measurement. What does it want you to do? Average acceleration.
So, going over v minus a.
No. Okay, because they didn't give me acceleration in the table. They gave me velocity. How are velocity and acceleration related?
Acceleration is the derivative.
They're the derivative, okay? And if I have real data and I want an average of that derivative, what do I do?
The
Y'all are thinking too hard.
trapezoid?
Nope,
Right.
nope. We don't have a function to take a derivative of, so how can I calculate a derivative? How can I calculate a rate of change if all I have is data?
Oh, the last one minus the first one.
I do the slope. Yep, we do the slope. Woo! Woo! Law, we tired. Okay, so we're going to do the slope, okay? So our average acceleration, all right, our average acceleration, v at 80, this is number 4, so it's non-calculator, over v at 0, over 80 minus 0. Right, so 49 minus 5 over 80, 44 over 80. You could reduce if you wanted to. Okay, if velocity is measured in feet per second, what's acceleration going to be measured in? There you go, feet per second squared. Okay, 1 point. The answer. Okay. The answer. Okay. Next part, 2 questions within 1. Sneaky heifers. Okay. Using correct units, explain the meaning of the integral from 10 to 70 of v of t dt in terms of the rocket's flight. Use a midpoint Riemann sum with 3 subintervals of equal length to approximate the integral. Okay. So I kind of like to start with the midpoint, but that's just me, all right? But we could start with the words, okay? The integral from 10 to 7 of v of t dt, all right? What's this going to tell me? All right, this represents the distance the rocket traveled from t equals 10 to 70 seconds. Okay. Now, if that's all you did, you'd get a point. Okay. Because sometimes we get in a hurry and we don't read the other stuff. And it says to use a midpoint, that one, Riemann sum with 3 subintervals. Okay, to approximate it. So we want to find 10 to 70 of v of t dt. We're going to use a midpoint, right? And so to do that, let's go up here from 10 to 70, right? I only want 3 subintervals. Okay, do you see that midpoint value it wants you to use? Okay. It gave it to you on purpose. Okay? So you could use it. So the length of each interval is going to be how much? 20. Okay? So that's good. So I'm going to have 20. I could actually pull that out if I wanted to. All right? Because they're all going to be multiplied by 20. Okay? Each interval is a distance of 20. Okay? And then the y values that we're going to use are 22, 35, and 44. Okay? Which would give me 20 times 66. Is that 101? Okay. Which would give me 0202. 2020. Oh, great number. And its feet. Okay. So, the second point came from using those y values. and your last point from the answer. So it was worth 3 points. Okay. All right. Now, the last part. It says rocket B is launched upward with an acceleration. All right, so it gives me the acceleration in feet per second at time t equals 0. The initial height of the rocket is 0 feet, and the initial velocity is 2 feet per second. Okay, so the initial height, so x of 0 is 0, and v of 0 is 2. Okay, which of the two rockets is traveling faster at 80 seconds? All right, so let's think about that for just a second. Okay, which of them is traveling faster at 80 seconds? What are we going to need to look at?
Velocity.
The velocity. Okay, we need to know the velocity of rocket B. I know the velocity of rocket A. It's in my table. Okay, they told me the velocity of rocket A. Okay, so I really need to know the velocity of rocket B. Okay, with respect to time would be the integral of that acceleration function that it gave me. 3, and I'm going to actually write it as t plus 1 to the negative 1/2 dt. Okay, because we're going to integrate that bad boy. Right. So if we do that integration, all right, that 3 we're going to keep. T plus 1's going to go to the 1/2. We're going to divide it by 2, and we're going to have a constant. And so that gives me 6 times the square root of t plus 1 plus a constant. All right. It gave me that initial velocity so that I could find my constant. Right. And so if I plug in 0, oh, it was 2, wasn't it? Okay, so 2 equals 6 times the square root of 1 plus c. 2 equals 6 plus c. c is negative 4. So my velocity function, v sub b of t, is 6 square root t plus 1 minus 4. Right? What I need to check is v sub b at 80. So square root of 81, isn't that a coinky dink? Okay, 54 minus 4, which is 50. All right, my units would be feet per second. Okay, so who is traveling faster at t equals 80? A or B? B is. Okay, so we would say rocket B is traveling faster at t equals 80, and here's why, because v sub b at 80 is greater than v sub a at 80. All right, that's our justification. This was worth 4 points, okay? You got 1 for the antiderivative, okay? You got 1 for the constant. You got 1 for doing v sub b of 80, and then you got 1 for your conclusion. Okay, so you got 4 points. Those are the things. Now, that means we're still missing a point. That 1 point came from getting the right units in A and B. Okay, so they gave you 1 unit point. You don't get half points for units, by the way. All right, you either get them or you don't. All right. Okay, so I'm tired. Are y'all tired? Okay, good. Let's write one more thing down and we're going to be done. Okay, just as a review, skip over 2 pages and let's go to where that box is for volume. I'm not going to see you for 2 days, so you got lots of time to practice. Okay? Because I know y'all all do when I'm not around. Okay, all right. So remember with volume, we had 3 methods. All right? We had cross sections. Okay? Where we build a shape on top of a region. Okay, again, it could be vertical and I build something out. It could be horizontal and I build something up. All right, so we use an area formula when we integrate. Okay, if it's horizontal, we'll use dy. If it's vertical, we'll use dx. Okay. Okay, remember when we use a disc, that's a cylinder. Okay, that's volume of a cylinder. All right, which is pi r squared times the height. Okay, which is pi r squared in our height. Our height being our dx or dy. Okay, so you're always perpendicular to the axis of revolution. Right. So if I use x's, it's pi times the integral from a to b. Remember, it's your radius. Your radius is that piece from the region, okay, that horizontal or vertical piece. Okay, or pi times the integral from c to d r of y squared dy. Okay. And then washers are where we have space. Okay. All right, still perpendicular. Okay. And this time we have the big radius, that's the top of the region. The little radius is where the hole would be. All right, but we're still doing a cylinder. So you'd have pi times the integral from a to b. Big radius squared minus little radius squared. Right? Or if we switch it, c to d, right minus left. Okay, so just as a reminder with those. Okay, and then the only thing that I added was another one of those day AP Live reviews. So from 2021, it is the day 7. Okay, there's a bunch of stuff back there for y'all to mess with over the next couple of days. All right. Good job. Thanks for hanging in today. I appreciate you. All right, letting us go through so much. When I see you again, which will be Friday. I know. I don't like not seeing you guys.
Why not tomorrow?
Because we're going to start in second stay all day because of today. And then we were already scheduled to do that for Thursday. Sorry. What do you have second block?
Personal finance.
Oh, sorry. It's okay. You'll have plenty of time to work on calculus. Yeah, I'm like, you'll have plenty of time. There won't be a lot going on in there. Yeah, I know. You're having to. Are you packed and ready to go Friday?
Not done yet.
Okay.
I'm trying to get my